In this video, we're going to be taking a look at how to calculate a derivative using that definition of the derivative that we just talked about. So that says the derivative of the function f is the function denoted f prime. We read that as f prime. And that is the notation that lets us know that this is the derivative of the function rather than the function itself. So the derivative of the function f is the function denoted f prime, whose value at the number x is defined to be the number and then here's where we get that definition that we talked about last time. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And then here's the key, provided that this limit exists. In another video, we will talk about the circumstances under which a function doesn't have a derivative. But in general, this is the formula that we're going to use to calculate the derivative. So let's take a look at a couple of examples. Let's say we want to, here we go, example, find the derivative of f of x is equal to x squared plus 7x minus 3. Okay, this is what I want to find the derivative of. Okay, how do we do that? Well, we think of our derivative formula, and it says f prime of x, or the derivative of f, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. The biggest difficulty that most students run into when finding derivatives is there are a lot of details and very nitpicky steps when finding the derivative, and there's a lot of algebraic manipulation that needs to happen. And if you don't keep all of that pretty organized and, follow the distributing of all your negatives and combine like terms appropriately, if you don't do all of that part, that's usually the part that people have trouble with, not the calculus, it's the algebra. So you want to keep this process as organized as humanly possible. So here's what I'm going to do. I'm going to color code it because that helps me, but you can find your own method. If color coding doesn't help you, if you need to do something else, that's totally fine. But we want to find the limit as h approaches 0 of this whole thing. Now, the first thing that we want to find is f of x plus h. That is the first term in the numerator of this formula to find the derivative. And what does that mean? Well, it means we're going to go to the f function, which is this one right here, right? The function that we started with. And everywhere that there was an x, we are going to replace it with x plus h. So what's that going to look like? Well, when I go to f of x, my very first term is x squared. That's no longer x squared. That's x plus h quantity squared. Then I have a plus 7x. That's no longer plus 7x. That's plus 7 times x plus h. And then I've got this final term, minus 3. I don't have to do anything with the h there, right? Because it's only the x's that I'm replacing by x plus h. Everything else is going to stay unchanged. If it's a constant, it's going to remain a constant. So that expression that I have written down right now, that is just the f of x plus h portion of finding the derivative. Okay, so that is the first step. The next step is to find minus f of x. Now, that's actually pretty straightforward because we're just going to subtract the function that we started with, right? The original f of x function. The trick is because we're subtracting the entire function, make sure to get a set of parentheses around this. That is one of the biggest issues that people have, is dropping those parentheses, because we're actually going to need to distribute that minus sign through the multiple terms of f of x. And if you don't put the parentheses there, most people don't remember to do that distribution. So when you go to subtract the f of x function, put parentheses around the entire f of x function. And so inside that parentheses, we're putting the original function, x squared plus 7x minus 3. And then the only thing from the derivative definition that we don't have yet is this whole thing, regardless of how long and awful that expression is all divided by h. Okay. So this is the first step. This is just setting everything up. And technically at this point, this thing that we've found, that represents the derivative. But in order for it to be the derivative, we need to simplify the expression as much as possible and then apply the limit as h approaches 0. And once we've done all of that, then we have found the derivative. Okay. So next step is we're going to leave the limit part here for now, limit as h approaches 0. And then we're just going to look at what can we simplify algebraically in this expression. Well, the first thing that I see is I have an x plus h quantity squared. And remember that that's x plus h times x plus h, right? That's what that represents. So when I square those two things, when I multiply x plus h times x plus h, I'm going to have to FOIL. So the x times the x, the firsts, that's going to give me an x squared. From the outers, I get xh, right? X times h. From the inners, I get another xh. So altogether, that's plus 2xh. And then from the lasts, plus h times plus h, that's a plus h squared. Okay, so that is from FOILing that first term together. Then we're going to distribute the 7 to the x plus h. So we'll have plus 7x plus 7h. And then we had a minus 3 that just hangs out. And then this negative in between the f of x plus h and the f of x, that's got to distribute through here as well. So then we'll end up with minus x squared minus 7x plus 3 all over h. And at this point, you can probably see all of those details that I'm talking about, right? If you drop a negative sign, if you forget to put a squared on something, it changes the entire value of the derivative. And so keeping track of all of those little tiny details is really, really crucial to getting the final answer to be correct. Then at this step, you'll notice that a lot of things will cancel. So for example, my first term is an x squared. I have a minus x squared down here. those cancel, right? I have a 7x, I have a minus 7x. Those cancel. I have a minus 3, I have a plus 3. Those cancel. So a lot of things just canceled. And when all the dust settles after all that canceling, what are we left with? Well, we have the limit as h approaches 0 of 2xh plus h squared plus 7h all over h. So each of these three terms in the numerator is being divided by the h. And so when I think about what that means, 2xh divided by h, well, that h would be gone, right? It would cancel out with the h in the denominator. The h squared over h, I'm going to be left with 1h in the numerator to cancel with the 1 in the denominator. And then 7h over h, that would cancel out as well. The h's would, and leave me with the 7. So at this point, we've got limit, as h approaches 0 of, what's left after all that canceling? 2x plus h plus 7. Now, as h approaches 0, that only affects this middle term, right? If h is approaching 0, that term also approaches 0. So what's my derivative? F prime of x is equal to 2x plus 7. Okay. Let's take one more example in this video, and then in the next video, we'll take a look at when do derivatives not exist. Okay, so here's another one. Let's look at let's take a look at finding the derivative of let's say f of x equals 1 over x. We'll look at a rational function. Okay. So again, thinking about our derivatives, that f prime of x, that is going to be equal to limit as h approaches 0 of f of x plus h minus f of x whole thing all over h. Okay. Now, what do we do with that? So same process as before. This one's going to be a little bit nasty in terms of the algebraic simplification, but the process remains completely unchanged. It is the same process. So we're going to start by doing our f of x plus h, meaning I go to my f function, and everywhere I see an x, I'm going to replace it with x plus h. So the limit part just carries down for now. And f of x plus h, well, I did have 1 over x, so f of x plus h is going to be 1 over x plus h. Then I have minus f of x, so I'm going to have minus 1 over x. And then that whole thing is all over h. And so at this point, you might be wondering, how in the heck do I simplify this thing in the numerator where I have 1 over x plus h minus 1 over x? Well, since they're both fractions, the way that we combine two fractions like that is to get a common denominator, right? And in this case, we've got x plus h here in the denominator and x over here. So what we in fact need to do is to take the first term, that is the 1 over x plus h, and we need to multiply by x over x, right? So really we're just multiplying by a fancy looking 1, but that's going to get that x into the denominator. And the second term, the 1 over x, we need to multiply it by x plus h over x plus h, because that's going to get that x plus h into the denominator. Similarly to how if your denominators, if you're dealing with, fractions that are not expressions involving variables, but if one of your denominators was a 3 and one was a 7, you would multiply the 3 by the 7, and you would multiply by the 7 by the 3, and you would end up with a common denominator of 21. Here we're going to do the same thing. Our common denominator is going to be x times x plus h. Okay. All right, so let's keep going with this and see how it looks next. So we have limit as h approaches 0 of, when I multiply these two things together, I have x over x times x plus h, and I'm actually going to leave the denominator in that factored form for right now. Then I'm subtracting, and again, don't forget a set of parentheses around that part that you're subtracting, because we're going to have to distribute that negative through. In the numerator, we'll have x plus h. In the denominator, we have x times x plus h. And this whole thing is still all over h. Okay, so at this point, what we're going to do is we can combine these fractions now because they have a common denominator. And we do that by, when we're subtracting fractions, we subtract the numerators and we keep the denominator. And here, subtracting the numerators is going to involve distributing that negative. So we have limit as h approaches 0 of x minus x plus h over x times x plus h. That's our common denominator. And then that whole thing over h. And you'll notice at this point, those x's are going to cancel. And then something very interesting happens. So we still have limit as h approaches 0. Now, this thing in the numerator, the thing that's all over h, right? What is that? Well, it's h over x times x plus h, right? And what are we dividing that by? Well, we're dividing it by h over 1, right? If my denominator is just a single number, I can always convert that into a fraction by putting it over 1. Now, what's the rule for dividing two fractions? Well, we take the fraction that's in the denominator and we flip and multiply. So this h over 1, we're going to multiply by 1 over h. Oops, and I just realized, you guys might have caught me out on this earlier. I had x minus x plus h. It's actually x minus x minus h in the numerator. I am so sorry about that. So this should actually be a negative h. I knew something didn't look right. Okay, so we have negative h over x times x plus h times 1 over h. And then because these are fractions that we're multiplying, we can cross cancel. So h goes in here one time. H goes in here and leaves us with a negative 1. And then, golly, I'm totally running out of room here. So we have limit as h approaches 0 of negative 1 x over x plus h. Okay. We have limit as h approaches 0 of negative 1 over x times x plus h. That's what we had, right? Let me check. Negative 1 x plus h. Yes, because this thing that we're multiplying by here, that's just a fancy number 1. So what does this mean? Well, as h approaches 0, when we take that limit, what happens here? This h becomes a 0. And what does that mean in terms of our derivative? Our derivative, f prime of x, is equal to negative 1 over, all I have now in the denominator is these two x's being multiplied together because the h is turning into a 0, negative 1 over x squared. And that is our derivative.